We're here about halfway through the course, and we're down to chapters 11 and 12. Let's take a look at that stuff. Here's chapter 11. So let me run the preliminary thing here. So we're going to talk about tuples. These are kind of fun. You can have sets of values treated as a single object in Python. I've gotten used to this. So here, you just make a comma-separated list of values. Now, you know, if you make a list, you'd put square brackets around it. But here, you don't put any brackets around it. You just put some values, and that's called a tuple. So you can print it. And if you print it, it's just that list in parentheses, not in square brackets. All right. And so you can enclose it in parentheses, but you don't have to. All right. So you can make a single element, and if you include a final comma, that makes it a tuple with one element, which is not the same thing as just an integer or a string. All right. And a single value in parentheses, however, is not a tuple. It's just a string. So anyway, there's also a function called tuple that will do it. And if you give it a sequence, tuple of Lupin, it will break the letters up into separate letters and give you a tuple of every letter. So, all right. You can't therefore use it as a variable name. And so you can refer to the elements the same way you would as a list. This will be the first element, number 0, and so on. Here you can go from the first element to, and the second element. It goes from first to the third, not including the third. So you get 2 elements. Plus, we'll concatenate tuples. So this is going to be LUP, and that's going to be IN. So you get Lupin. And you can multiply, of course. Spam, spam times some number, spam, spam. All right. You can sort tuples with sorted, but if you do, you end up with a list, not a tuple. And you can reverse tuples, and this will tell you the reversed object is there, and you can convert that object to a list or a tuple. So it's a little screwy, but that's how you reverse the order of a tuple. All right, they seem an awful lot like the same as lists, but tuples are immutable. So if I try to change the value of t0, it's going to not let you. So that's the difference between tuples and lists. And they don't have things like append and remove. You can't remove the L from there. So tuples are simpler in a way. All right. Because they're immutable, they're hashable, so you can use them as keys in a dictionary if you want to do that. I don't know why you'd do that, but you could do that. You could have d of the tuple 1, 2, and d of the tuple 3, 4 equals 7. You can look up 1, 2. If a variable that refers to a tuple, it can be a key in a list, of course, and they can appear as values in a dictionary. Key, and that's ABC. Well, sure, it can be the key or the value, of course. That would make sense. All right. This is what I actually do, which is quite useful. If I have to reverse 2 values, for example, let me just do it up here. If I have to reverse 2 values, if I have like A equals 1 and B equals 2, and I want to flip these, then the cool way to do it in Python, which you can't do in any other language I know of, is you can set BA equals AB. Now print AB, AB. And now A should be 2 and B should be 1. Need a comma here. Yeah. So I thought this is cute. That's one use of tuples. This tuple is that tuple. All right. So you can do this. You can assign 2 values at once. AB is 1, 2. And so it's going to be 1, 2. All right. The right side can any kind of sequence. I can set user main domain equals this split. So it'll give me monty@python.org. The number of variables have to be the same, though. So if I have AB equals 1, 2, 3, that, of course, doesn't make any sense. You can't do that. All right. So how do you do this here? Swap the values. This is the way I used to have to do it. You used to have to use a temporary variable to do it in other languages. But with Python, you can do it this way. AB equals BA. All right. And you can use a for statement for item in D items, which is going to be these 2. Key value equals item, and print the key value. Okay, this is going to one way to print the keys and the values of a dictionary. Okay, that's cute. So the item is a tuple. it's going to be those two objects. I wonder if item is a tuple. Actually, let's see. Let's print and type of item. I'm not sure what the what an item from this D items thing is. The item is a tuple. Oh, okay. So each one of these is turned into a tuple. 1:1 is turned into 1:1, a tuple. All right, fair enough. That's what this items thing does. All right. So, okay. You can write it more concisely for key. Right, you can do this. I've done this too. For key value in D items, that will move both of them through the list together, which is kind of handy. All right. And you can return a tuple. So div mod takes two arguments and returns a tuple of two values, the quotient and remainder. So if I take 7 and divide by 3, I should get 2 with a remainder of 1, because there's 2 3s plus 1. Yep, so there's the integer division, and here's the remainder. All right, so you can set those to quotient dot remainder and put them in variables. All right, and this kind of thing is quite useful. Actually, this part of tuples I use quite a bit. That's actually easy to understand and useful. Here's a function that returns a tuple, min and max. It will go through a list, and it will find the minimum and the maximum value in that list, I guess, all right, of a sequence. So if I have a sequence of 2, 4, 1, 3, it'll return 1 and 4, the lowest and highest, all right? So you can make low and high equal to min, max, and there they are, low and high. So you can have argument packing. And of course, the thing that got me aware of this first was I would connect to a port. We did that in much earlier projects. And when you use a connect to a port, let me bring that up. That was an earlier project back here. Right, port scanning. Here, when you connect to a port, the reason you have two parentheses here is because the connect function does not have two parameters. It has one parameter, which is a tuple. The URL and the port number are a tuple. That's when I first came across it. It's a little bit subtle, but that's why there's two sets of parentheses there. All right. Anyway, so you can pack a bunch of arguments in with the tuple. So this function will take any number of arguments and calculate their mean. All right. And so you can pass it 1, 2, and 3, and it'll take their mean as 2. A sequence of data values, and when I pass them in multiple arguments, you can use the star operator to unpack the tuple. So div mod takes exactly 2 arguments. So if you pass it a tuple, it's not going to take it because that's 1 argument. You'll have to unpack the tuple with star t. Star t will turn it into the argument. So, all right, that's the thing to know about star. All right, so you can pack and unpack. Here's a function that takes any number of arguments, removes the lowest and highest, and so it's going to make a list and remove them, trimmed, and then return the mean of the rest. Okay, fair enough. That's interesting. All right. So here's an example. I have 1, 2, 3, 1, 10, so it should take away 1 and 10 and average 2 and 3. And that doesn't look right. First it's going to use min and max. Then it's going to trim, remove the low and remove the high. Then it's going to return the mean of what's remaining. So at this point, if I print trimmed, that's why you had to debug problems. Let's define it that way. Now when I run it, well, that's rude. Oh, this is mean. Oh, I didn't pay enough attention. This is mean of those, which is 4. 1, 2, 3, 10, because this is 10 plus 16. Okay, but trimmed mean should be the average of 2 and 3. I see, it's working. Okay. So I don't really need this. That's something I added because I was confused. All right. So this is the difference between a normal mean and a trimmed mean where you throw away the outliers. Okay, fair enough. All right, and then there's zip. I've certainly seen this used a lot, although I haven't used it much myself. So if I have two lists that are the same length, like the scores of two teams playing games, then I want to see how many games each team won, comparing this score to this score and this score to that score. So you can use zip that will return a zip object that matches these together like the teeth of a zipper. So for pair in zip, print pair, that's going to find the pairs and print them out. But I didn't run this to define it. Okay, there we are. So now you match them up, 1, 5, 2, 5, 4, 2. It's a way to pair up two lists that are equal length. All right, and so now you can count the wins. If team 1 is greater than team 2, then wins goes up. So this is how many wins there were for team 1. Looks like team 1 won here, and here, and here. So that's 3 wins. All right. If you have two lists and you want a list of pairs, you can use zip and list, right? You can do the zip to pair them up and then make a list of them. And now you get this list, a list of pairs, instead of two separate lists. We have to match them one by one. So that's a list of tuples. So you can get the result of the last game like that, tuple, the t of -1. And if you have a list of keys and values, so I'm going to have letters and then numbers. All right. And now you can make zip to zip them together and dict to make a dictionary. And so now I'll get a dictionary that shows 0 letter map of A and letter map of Z. Right. Well, what we didn't do is print out letter map. Let's print out letter map. There. So A is 0, B is 1, C is 2, and so on. This will convert letters into numbers according to that. So this is going to be, the map of A is going to be 0, and the map of Z is going to be 25. All right. Fair enough. If you can loop, you can do enumerate. If you want to loop through them, that'll give you an enumerate object, and you can make it a, for index element in the enumerate object, print the index and element, and that's going to give you A, B, and C. All right. Index element in enumerate of A, B, C. Now, 0 to A, one thing that's confusing me here is I don't see this getting back to the letter map. Oh, each pair contains an index and an element. So these indexes are just generated, but they're not equal to those indexes. I find this example a little confusing. Let's make this TUV. And now TUV. There, and now you can see it's just started counting at 0. So this is not connected to that map up there, although it happened to look similar. Okay. All right. And you can compare tuples and other sequences. It's going to compare the first element, and if they're equal, it goes on to next. So I can compare 0, 1, 2 to 0, 3, 4. The zeros are going to match, but the 3 is bigger than the 1, so this should be true. And it is. Okay. And its subsequent elements are not considered, so 3 is bigger than 1. And so even if this, in this example, even if this is bigger than that, it's not going to matter. It's still true because it stops as soon as it finds the first one that it can compare. So the zeros are equal, but 3 is bigger than 1, so this is true. All right. And so here we made a function called value counts that takes a string and returns a dictionary that counts how many times each letter appears. And so if you run it on banana, you get, there's 1 B, 3 A's, and 2 N's. All right. You can get the items from counter like this. Okay. And then you have a list of tuples, where tuples is the number, the character, and the number of times it appears. All right. And so you can sort it. And now the first one is going to be the one that appears the most often. The default is to use the first element to sort list. So it's going to sort them by A, B, and C. That's right. Okay. So this is sorting by the first one, just putting them in alphabetical order. If I want to use the second element to sort the list. So what I'm going to have to do is write a function that returns the second element, and now pass that to sorted as what the key is going to be. So you sort this, but the key is going to be the second element. Now I'm going to get 1, 2, 3, sorting by count. All right, those are pretty useful manipulations. All right, and there we are. We can find the most common letter like this. It'll be the one at the end of that sorted list. And if you want only the maximum, you don't have to sort the list. You can use max, which will find the maximum of the second element. All right. All right. So you got a dictionary where you look up a value and get the key, but maybe you want to reverse it and have, now the keys have to be unique, but the values don't. So one way to invert a dictionary is to create a new dictionary where the values are a list of keys from the original. Okay, let's see if I can figure out what this is. So I'm going to count parrots. So that's going to give me this P, A is 1, R is 2. Okay. If we invert this dictionary, the result should be 1 matches to all these. I see. Those are ones that appear only once. Here's the thing that appears twice. Okay, that's interesting. I guess you might want that under some conditions. So this will take that dictionary, and if the value is not in new, set new of value equal key, else add 1, append the key here. Okay, that'll do it. So that will invert there. Yep, 1, this is how many times these letters that appear only once, that's the letter that appear twice. All right, getting a little twisted, but you can do that. All right, and their data structures. So there is a thing called struct shape that takes any kind of data structure and summarizes it. I've certainly never used this. It's something the author wrote. So this is going to tell us a list of 3 integers. Okay. Here's a list of lists, a list of 3 lists of 2 integers, and list of 3 integers float to. Okay, well, I'm not sure exactly how valuable that is, but it is possibly useful if you want a description in words of these objects. Okay, well, that's it for Chapter 11. Let me stop this one.